Welcome to Web Handling. My name is Dave Roisum. In this third in a series of YouTube clips, we discuss one of the most common of curl mechanisms, lamination. Laminator curl is so common that you should expect it, rather than be surprised or disappointed when it happens. The reasons are technical, and they were covered in great detail in our Web 101 class. Here, we will merely provide an executive review and explain what your effective options will be. Returning to the why. Curl is common for two reasons. The first is that product designers and customers alike may want plies that have different properties. One of the properties that will likely be different between the top and bottom plies is modulus, even though you seldom care about modulus per se. The other part is that once you choose materials, the only effective knob you have left to move curl, in most cases, is the tension of the low modulus side. Simple enough, but the problem with tension is that it is over-constrained. By that, I mean that you want to drop the tension of the low modulus ply until it is painful. What painful means is that it is likely that the laminator won't run well because of minimum tensions. That we covered in our Web 101 class in great detail. However, the over-constraint is not strictly confined to machine runnability. Bagginess and other high-order properties may also contribute or create curl. In mathematical terms, you have more equations than unknowns. In layman's language, troubles are more or less guaranteed. Recall from our Web 101 class that we can model curl precisely. What model means is that we can quantitatively predict behavior. Not just whether curl will happen, but exactly how bad it will be and what you can do about it. We can do this without even running trials in most cases. One simple model can even run with your thumbs on a smartphone, as we will see. Also from our Web 101 class, we listed some of the constraints on tension. Without getting technical, you are simply being asked to do too many things with one knob, namely the tension of the low modulus ply. It is not possible, for example, to have the knob low to solve curl and at the same time high to solve other problems. As promised, we will not dive into the tech in this clip. Instead, we will look at the curl problem from 10,000 meters up in the executive jet. For existing products, there are two steps. The first is to reduce tension on the low modulus side of the laminator so much that it is clearly painful, and then even go further to make sure you understand the low tension pain. The second step is to choose your balance between what would be similar levels of pain on the laminator runnability and curl complaints from the customer. Once you choose materials, pain from both sides simultaneously is the best that economics will allow. Once you choose material, pain from both sides simultaneously is the best that physics will allow. On new products, you may have a bit more leeway. This principle is called DFM, or Design for Manufacturability. In other words, to the extent economically possible, we may choose materials that have less dissimilar moduli while still satisfying other needs. When DFM is not at all possible, then we can build runnability waste and customer complaints into the economic forecast so that people are not blindsided and disappointed after the fact, especially since curl troubles are so clearly predictable. Of course, all of this requires an understanding of the problem, specifically the mechanics of the problem. Send your people to school to learn about these and other must-know mechanics of web handling. Training would be especially important for product developers, customer sales and service, as well as process engineers and lead operators. Product developers and process engineers then can even go a further step by making use of models for predicting curl. A simple 2-ply model, the Laminate Curl Calculator by Abbott App, is free, easy, and can be run on almost any smartphone, tablet, or laptop computer. For more than 2 plies, or to model the hygrothermal problem, you can consider its big brother, TopWeb. Even though TopWeb is not free, the cost is less than a single lost roll or a single customer complaint. If you have the opportunity for a new machine, you have even more options to help increase the range of what you can run. We covered this in detail in Web 101, but would include dual drives, ultra-low tension legs, and other options. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for the next clip where we will talk about coating curl. Here we will show that coating acts just like, and is in fact just another laminate ply.